Hi, my name is Adrian Tregonning, and this is a tuning morpher, a real-time tuning morpher. Yes, ever since last semester I became really interested in different tuning systems, from studying psychoacoustics and looking at consonance and dissonance and how that affects the tuning of various instruments. So I wanted to build a tool to be able to test that out for different instruments and different pieces of music. So what I've done is I've built this simple, straightforward tool that integrates with JScore, where you can go from a couple of different preset tuning systems, and you can sort of mix between them as much as you want. So, for instance, if we just play to start off with, we've just got a simple scale with the sawtooth wave, a couple of simple cadences at the end. So yeah, the default setting with JMSL is to put things into 12-tet equal temperament, which much of Western music is based on. But if we go over to the destination tuning column, we can choose from a few different options, a couple of different just intonations, and this Oho one I'll talk about a bit later. So if we look at the Pythagorean, we can see the frequency ratios here. So the first step is obviously the fundamental, and then you have the multiplier for the frequencies going up. And you can choose a mix between the two. So for instance, if I choose 100%, it'll spit out the exact Pythagorean tuning. Or I can choose somewhere in between and it'll pop out something in between. I can use different interpolation methods to come up with that value. So let's hear the Pythagorean to start off with. I mean, it's a bit hard to tell hearing them separate like that, but if we sort of just loop this last section, which is... And yeah, I chose a sawtooth wave because a lot of time these different systems, a lot of the effect comes into the harmonic structure. So for instance, when you have a complex tone, the way that the overtones line up is going to be different in different tuning systems. So for instance, in a just in tone system, if you have the upper harmonics of a fifth, the even harmonics will be the odd harmonics of the fundamental. They'll line up perfectly, so you get a more consonant, sort of straightforward sound, I guess. But in an equal temperament system, they're slightly offset, so it's a bit more complex, a bit, I guess you could say richer or something like that. But anyway, so if we go back to the original 12-tet and just play this section on the loop. Change the tuning. So if you listen closely, you can hear a bit of a difference. And yeah, so this tuning adjustment works in real time. So if I just play the whole piece, I can sort of jump to another tuning midway through. Alright, so yeah, these So in the program, I've just defined a whole bunch of different arrays with the different values. Some of these are drawn from, for instance, the Tell Me one. There was already a Tell Me tuning built into JMSL. Others I've sort of looked up. I mean, equal temperament's pretty straightforward. And this one here, the Oho ratios. Last semester, I did a paper on dissonance curves, like sort of based on Sitharas's work, who sort of hypothesized that by looking at the dissonance of the harmonic spectrum of an instrument, you can come up with likely candidates for scale intervals by looking at the consonance and the dissonance, I guess. So I analysed spectrum of the Chinese erhu, which is like a fiddle, and I came up with some different scales, different frequency ratios to use. And from analysing erhu pieces, they actually matched up pretty closely. It didn't necessarily describe musical or melodic structure, but it described the intervals pretty well. So yeah, I tried using these ratios in a tuning system, and I think it's probably something to do with the fact that it's a saw wave rather than an erhu. It sounds pretty wacky, but...
Nice.
And also because the erhu scale is heptatonic, I sort of just padded out some of the diatonic steps, so it can be sort of notated properly with the MIDI pitches. So yeah, I think this is a pretty cool tool. It could be pretty useful to implement as you're sort of writing a proper composition. Or, I mean, the heart of the whole thing is this method, making interpolated tuning, which just grabs the data from these tables. Oh, by the way, you can sort of manually make up your own, systems to go from and to. So, if you're crazy, things jumping about, and it'll show up in the more tunings. Yeah, I mean, so my original idea was to have a piece that changes tuning throughout. I didn't get that far to actually compose the piece, but all you'd have to do is, either on a repeat or, with have some predefined kicker that just calls this function and changes the tuning. Yeah.
Very cool.